In our fast-paced, information-rich world, especially, within a field as explosive as artificial intelligence, it can often feel like you're caught in a digital downpour. How do you cut through the noise? How do you get to the core of what's truly impactful? How do you make sense of concepts that sound, well, maybe intimidatingly technical? Well, that's exactly our mission today. We're diving deep into a concept that's rapidly becoming central to how successful AI applications are built: context engineering. Now, I know what you might be thinking. Context engineering sounds incredibly specialized, right? Maybe even a bit like jargon. But don't let the name deter you. We're going to demystify it and show you why understanding this isn't just for AI developers. It's a critical lens, really, to view the future of intelligent systems, and it's going to give you a significant edge in understanding what truly makes AI agents tick. And just for clarity, when we say LLM, we mean large language models, those powerful AI models like ChatGPT, and agentic systems. Those are AIs designed to actually do things, interact with the world, not just chat.
That's right. Our goal here is to unpack this powerful idea. Let's clarify its definition, really understand its significance, and differentiate it from concepts you might already know, like, say, prompt engineering. We'll also walk through some real-world examples to see it in action. And yeah, our insights today are primarily drawn from a recent, very relevant article called The Rise of Context Engineering.
And remember, this deep dive, it's crafted specifically for you. Whether you're prepping for an important meeting, trying to stay ahead on the AI curve, or maybe you just have that insatiable curiosity. We're here to provide those aha moments without, burying you in academic language. So let's jump in. Okay, let's start with the definition itself. The article states that context engineering is building dynamic systems to provide the right information and tools in the right format such that the LLM can plausibly accomplish the task.
And it mentions this builds on ideas from people like Toby Lutke, Ankur Goyal, Walden Yan.
Right, key thinkers in this space.
Yeah.
Okay, that's quite a bit to take in. Let's break it down. First, this idea that context engineering is a system. Why is it important to think of it as a system and not just, a clever trick or a single prompt?
Well, what's fascinating here is that complex AI agents, they're constantly pulling in information from so many different places. Just think about it. There's context from the developer who defined the agent's purpose. There's context from your specific input as the user, from all the previous turns in a conversation, maybe from the result of internal tool calls, or even data from external databases.
Right, so many sources.
Exactly. A single prompt just can't capture all that complexity dynamically. So seeing it as a system really emphasizes the orchestration needed. You have to gather and present all these disparate pieces of information cohesively to the LLM. It's about bringing order to what could otherwise be, informational chaos.
And that system isn't static, right? The definition explicitly says it's dynamic. What does that mean in practice? Because I think many of us imagine a prompt as something sort of fixed, like you write it once and use it.
Exactly. And that's a crucial distinction here. Context is almost never static in a real-world application. It changes constantly. With every new user query, every new piece of data, every single action the AI takes. So the logic that constructs the final prompt sent to the LLM, it can't be a fixed template. It has to be able to adapt. It has to build that prompt on the fly based on the ever-changing context.
Okay, like a customer support AI you mentioned earlier.
Perfect example. Its context dynamically shifts, right? From understanding the initial problem to maybe recalling past interactions to fetching product details from a database, all within moments. A static prompt would just completely fail there.
That makes perfect sense. Okay, then we move to you need the right information. This sounds incredibly obvious, almost trivial, but why is it often such a sticking point for AI systems?
Yeah, it sounds simple, but it really boils down to the garbage in, garbage out principle, maybe with an AI twist.
Yeah.
LLMs are powerful, yes, but they aren't mind readers. They operate strictly on the information they're given.
Right.
If you ask an LLM to recommend a restaurant without telling it, your location or cuisine preferences or budget, it can't magically infer them.
It has nothing to work with.
Exactly. It needs that explicit, necessary information to plausibly perform the task. A lot of AI failures aren't because the model is dumb, but simply because it wasn't given the basic facts it needed.
And it's not just information. The definition also stresses the right tools. Why are tools so crucial?
Well, information is one thing, but often an LLM needs to do something with that information, or it needs to fetch more information from outside its internal knowledge base. It might need to, say, search the web for real-time stock prices, or query a company's private database, or maybe even send an email, or interact with some other software API.
Okay, so it extends its reach.
Precisely. Giving the LLM the appropriate tools, and just as importantly, defining how to use them, clearly empowers it to go beyond its pre-trained knowledge. It lets it interact with the real dynamic world. Without the right tools, it's like having, I don't know, a brilliant chef, but absolutely no ingredients or cooking utensils. Limited.
And here's one I think many people might underestimate. The format matters. Why is formatting so important when you're talking to an LLM?
This is huge. Think about human communication for a second. If I give you a clear, concise instruction, you can act on it pretty easily. If I give you a messy, unparsed stream of consciousness, you'll struggle, right?
Definitely.
Well, same applies to LLMs, maybe even more so. If you provide information as just a huge, unstructured block of text, or maybe a poorly structured JSON object, the LLM might struggle to pull out the relevant details, or it might misunderstand the relationships between different pieces of information. Even the input parameters for the tools you give it, they need to be clearly defined and formatted so the LLM can actually use them effectively.
So it's about making it easy for the model to digest, minimizing its cognitive load, like you said.
Exactly. Maximize digestibility. Minimize confusion.
Okay, finally we get to this core question. Can it plausibly accomplish the task? Why is this the acid test, as the article seems to suggest, for context engineering?
This is your critical diagnostic tool. It really forces you to distinguish between two very different fundamental failure modes in AI agents. Is the AI failing because you didn't give it the necessary context, maybe the right info or the right tools, or perhaps in the right format? Or is the underlying LLM itself simply not capable of performing that specific task, even if you give it absolutely perfect context?
Okay, that's a key distinction.
It's incredibly important because it dictates your very next step. If it's a context issue, you iterate on your context engineering. Yeah. You tweak the system. But if it's a core model limitation, well, you might need a different model altogether, or maybe you need to rethink the task itself, make it simpler. Getting this right accelerates debugging significantly, makes building reliable systems much faster.
Yeah, that distinction really changes your whole approach to troubleshooting, doesn't it? It stops you blaming the model unfairly, perhaps. Yeah. So now that we have a clearer picture of what context engineering is, let's explore why it's becoming such a critical skill. It seems that when these sophisticated AI systems fail, it often comes back to the LLM messing up. But maybe not, because the model itself is inherently bad.
Precisely. If you look at the root causes of LLM failures, especially in these agentic systems, it usually comes down to one of two main reasons. The first, and actually less common reason, is that the underlying model just isn't good enough for the task. It genuinely lacks the raw capability. It needs more training, bigger size, whatever. But the second reason, and critically, more often than not, especially as these models just keep getting more powerful the mistake, is because the model wasn't given the appropriate context to generate a good output.
So it's not that it couldn't do it.
Exactly. It's that it wasn't set up properly to do it. The potential was there, but the necessary conditions weren't met.
And the source boils down that bad context scenario to two main culprits, right? Either there's just plain missing context, the models aren't mind readers, like you said. If you don't provide the information, they can't just invent it.
Correct. They can hallucinate, but that's not the same as knowing.
Right. Or the context is formatted poorly. Like that game of telephone, if the message gets garbled along the way, the final result will be off too.
Perfectly put. Communication breakdown.
And this leads us to something I find particularly interesting. The distinction between context engineering and that term we've heard a lot more, prompt engineering.
Mm-hmm.
How has our understanding kind of evolved here? Because for a while, prompt engineering was the big buzzword, all about finding that, magic wording.
You're absolutely right. Early on, the focus was very much on the clever phrasing of prompts. It felt almost like writing a perfect spell or incantation to conjure the right output. But as AI applications have grown way more complex, involving more steps, more tools, more data, it's become abundantly clear that while, yes, good prompt phrasing is still important, providing complete and structured context to the AI is actually far more critical than just tweaking specific words.
So we've moved beyond just the magic words.
We've moved beyond searching for the perfect incantation to focusing on building the perfect environment, the perfect setup for the AI to succeed.
So if I understand correctly, then context engineering sort of encompasses prompt engineering. It's not a replacement, but a broader concept.
That's a great way to put it, yes. Prompt engineering becomes a subset, a component of context engineering. You absolutely still need to carefully craft the final prompt that goes to the LLM. That's crucial. But now you're thinking about designing a system that dynamically gathers, selects, and formats all the necessary data into that prompt. It's less about just writing a static input and more about managing the dynamic flow of context into the prompt. The prompt becomes the vehicle for the engineered context.
Okay, I can see how those lines could blur sometimes. For instance, clearly detailing an LLM agent's role or its constraints within the prompt itself, is that context engineering or prompt engineering?
That's a perfect example of the overlap. It's both, really. Defining the agent's behavior and constraints its persona or rules is absolutely part of prompt engineering. You're instructing the model. But if we look at the bigger picture, those instructions are also a vital piece of the overall context that enables the LLM to plausibly accomplish its task within those defined boundaries. So yeah, it's an example where the concepts meet, showing how prompt engineering is really integrated into the larger context building effort.
Okay, let's make this even more concrete. Could we walk through some real-world examples of context engineering in action? The article had some good ones. Let's start with tool use.
Yeah, tool use is a fantastic example. Good context engineering here isn't just about giving an agent access to, say, a calculator tool or web search tool. It's also critically about ensuring the information returned by that tool is presented back to the LLM in a way it can easily understand and use. So if the tool fetches stock prices, good context engineering means structuring that data cleanly, maybe presenting it as a brief, descriptive sentence like, the current price of XYZ is $150, rather than just dumping a raw, complex JSON blob in the model.
Makes sense. Then there's short-term memory. We've all experienced that frustration with a chatbot that seems to forget what we just said 2 minutes ago.
Right. Context engineering for short-term memory tackles exactly that. It often involves dynamically creating summaries of the ongoing conversation. This summary, or sometimes a relevant portion of the raw conversation history, is then automatically inserted into the prompt for the next turn in the same interaction. It's how the LLM maintains coherence and appears to remember what you were just talking about. It keeps the thread alive.
And what about taking that a step further? What about long-term memory?
This is where it gets really powerful, I think. Imagine a user tells an AI their dietary preferences, maybe I'm vegetarian, or their favorite music genres. Good context engineering means the system can store these preferences, perhaps in a user profile database. Then, it can dynamically fetch that stored information to inform a completely new conversation, maybe weeks or even months later. The AI can then tailor recommendations or responses based on those deeply remembered preferences, creating a much more personalized and useful experience.
That feels like a significant step up. Okay, and as we touched on, prompt engineering itself still plays a role here as a component.
Absolutely. Within the broader context engineering system, the prompt is still where you clearly lay out detailed instructions for the agent's behavior. You define its persona, maybe specify required output formats, set constraints. You're basically setting clear guardrails and expectations for the LLM to follow. That's a critical piece of the overall context you're providing.
Right. And finally, the article mentions retrieval. What does that look like?
Retrieval, often called retrieval augmented generation or RG, is about dynamically fetching highly relevant snippets of information. This could be from a vast knowledge base, like a company's internal documentation, or a specific database, and inserting just those relevant pieces into the prompt right before you call the LLM. This ensures the model has the most up-to-date and specific facts it needs for the task at hand, without having to somehow hold all that information in its immediate memory or rely solely on its training data. It's like giving it specific cheat sheets just when it needs them.
It's a precision information delivery system. Yeah. Okay, so you can really see how each of these examples, tool use, short-term memory, long-term memory, prompt instructions, retrieval, they're all about ensuring the right information and the right tools are delivered in the right format. And crucially, that this is happening dynamically, adapting for each specific query or situation. Now, given how absolutely critical context engineering is becoming, it's probably no surprise that specific frameworks and tools are emerging to support this approach. The article mentions things like LangGraph and Langsmith as examples of tools explicitly designed to enable effective context engineering. So it's moved beyond just theory into, practical infrastructure.
Yeah, and what's really significant about these types of tools is how they address the practical challenges developers face when building these complex systems. They really emphasize two key principles. First, control. Frameworks like LangGraph aim to give engineers precise control over every single step of an agent's execution flow. You can dictate exactly what goes into the LLM, how intermediate results are processed, where outputs are stored, how loops happen.
So you're not just throwing things at a black box.
Precisely. This granular control is essential because it directly combats the limitations you might find in more abstract, perhaps older, agent frameworks that might obscure or restrict your ability to really fine-tune the context flow. The source even talks about this idea of 12-factor agents and principles like own your prompts and own your context building. It perfectly aligns with this push for explicit control.
Okay, so control is one. What's the second principle?
The second is observability and debugging. This is huge. Tools like Langsmith allow you to trace every single call an agent makes. You can literally see the exact inputs that went into the LLM, the exact outputs it produced. You can verify that the correct data and tools were provided, and you can check if they were in the right format. This level of visibility is absolutely crucial for debugging complex agent behavior.
Because otherwise you're just guessing why it failed.
Exactly. It lets you confirm that your engineered context is actually delivering what the LLM needs to perform the task reliably. Without this kind of observability, context engineering would be largely guesswork. You'd be stuck dealing with a black box, never quite sure why things are going wrong.
So really, it's not about promoting specific products here, but about the underlying principles these kinds of tools embody, needing that granular control over data flow and needing crystal clear visibility into every step. These seem like the absolute cornerstones for doing context engineering effectively.
Couldn't agree more. And this brings us back to what I find to be the really overarching kind of profound insight from the article. This idea that communication is all you need. What's fascinating here is the emphasis on how profoundly difficult and frankly often underestimated effective communication with LLMs truly is. It's so often the root cause when AI agents make errors. It's frequently not a fundamental flaw in the LLM's raw intelligence.
But a breakdown in the dialogue.
Exactly. A breakdown in the dialogue we're trying to establish with it. It's like trying to have a really nuanced conversation in a language you only half understand, or with someone who needs instructions laid out just so.
And that ultimately feels like the big takeaway here. While context engineering might be a relatively new term hitting the mainstream, the underlying practices, the focus on setup and communication, has been quietly shaping the success of complex AI applications for a little while now. It's a term that perfectly captures an increasingly vital skill, one that is rapidly defining the success, or indeed the failure, of sophisticated AI systems. It really highlights that it's not just about the model's innate intelligence, it's about how intelligently we communicate with it, how well we provide it with the perfect stage to perform. So what does this all mean for you listening right now? Well, understanding context engineering gives you a powerful new lens, a way to view the capabilities and, maybe more importantly, the limitations of modern AI. It shifts the focus. It's not just about what the AI can do inherently, it's about how well it's been set up to do it by the context it's provided. It moves us away from just hoping for magic prompts and towards engaging in more thoughtful, systemic design when we build or even just use these tools.
And this raises, I think, a really interesting question for you to consider moving forward. If the next major frontier of AI development is truly mastering this art, the art of providing precise, dynamic, well-formatted context to machines, what implications might this have for how we ourselves, as humans, will need to learn to communicate more effectively, more intentionally, both with AI, obviously, but maybe even with each other, in a world that's going to be increasingly shaped by these intelligent, context-dependent systems?
A truly powerful thought to end on. Thank you for joining us on this deep dive into the world of context engineering. We hope you feel a little more informed, perhaps a little more curious, and definitely ready to tackle the complexities of AI with a fresh, empowered perspective.